All right, guys, before we get started, are there any questions on the homework? Questions over any of the homework assignments? All right. So where we stopped off yesterday is sum or difference of two cubes. And there's a set pattern for how these work. Now, the first thing we can do is take the cubed root of both of our terms. Now, we don't specifically have to write it out, but it is sometimes helpful to have it written out so we can see what our two terms are going to be. Now, the first one, the cubed root of x to the third is, well, x, because our cubed root and third power cancel each other out. Now, for our other one, the cubed root of 64, well, we can do that in a calculator. We can do 3. Second nth root. 64 is 4. So this does tell us that this is a difference of two cubes because x to the third and 64 are both cubic. And that leads us to setting our problem up. So we'll have two sets of parentheses. One will have 3 spaces, the other will have 5. And the first thing we can fill in is our signs. Now the signs are going to be the same, opposite, always ended on a positive note. So here, starting off, our first sign is the same, so negative. Opposite would make it positive. Always ended on a positive note would be plus. So minus, plus, plus. Now our first term is our x. So in the first set of parentheses, our first spot would be x. In the bigger one, we're going to have our first term squared, so x squared. Then our first term to the first power. And then the last one's technically that term to the 0 power, but that's 1. So it simplifies out. We don't have to put it. Questions on this so far? Our other term is 4. So the first set of parentheses is just going to be x minus 4. In the bigger set of parentheses, in this first spot here, we would have 4 to the 0, which is going to be 1. We don't have to list it. In the middle, we would have 4 to the first. And in the last one, we'll have 4 squared. So realistically, in the bigger set of parentheses, the first term is going squared first 0. And the second term is going to the 0 power to the first power and then squared.
Is there a footnote?
They're not specifically in there, but the pattern, luckily for this, stays the same. Because same for sum, plus, same, opposite, positive note. Our first and second term, and then square, first, 0, 0, first, square. And it repeats on both. Now, the last thing we need to do is simplify. Now, if you want to write those down, we can go back to them and I'll leave them up at the end. Now, the first thing we're going to do is simplify our x squared. Well, that's just x squared, because x times x is x squared. Plus, x times 4 is 4x. Plus, 4 squared is 16. So x cubed minus 64 factors to x minus 4 times x squared plus 4x plus 16. Interestingly enough, the second set of parentheses, this quadratic, will never factor, no matter what it is, for any of our sum or difference of two cubes. It is never factorable. And its solutions, if we solve for this part, will always be complex solutions every time. So we're going to look at our next one here, 27a to the third plus 64. So we'll take the cubed root of our two terms first. Well, luckily out of these two here, we do know one of them. The cubed root of 64 is 4. Cubed root, so we're trying to find out what number times itself 3 times is 64. Well, so we would do 3 second nth root, and then we can do our other number 27, and the cubed root of 27 is 3. So our A it cancels it out, because if we did say the cubed root, let's go cubed root of 3 to the third, which is 3. So our cubed root of A to the third is just A. Okay, so we have our two terms. It does tell us this is a sum of two cubes. So we need our signs. Our signs are going to be the same. Opposite always end on a positive note. So for it to be the same, we would have plus. Opposite would be minus. Always end on a positive note would be plus. Our first term in this case is 3a. And we can go on and fill the first terms in. So in the bigger set of parentheses, in the first spot, we would have our first term squared. Then we'd have our first term to the first power. Then we don't have one. Questions on how we filled this in? Our second term is 4. So we fill it into the other spot in the first one. In the bigger one, we don't have anything with our 3a squared. In the middle, we would have our 4 to the first with 3a. And in the last one, we have 4 squared. So here, we really do have 4 to the 0 power.
So what do you mean when you say you don't have a number to go with it?
We're not going to put something here with it, or the 3x over here, or 3a over here.
So would there be something that would go with it?
Well, really, it would be 3a to the 0. Anything to the 0 power is 1. So I'm going to write this off to the side. So we're saying that we have 3a to the 0 times 4 squared. Anything to the 0 power, so this is 1. 4 squared is, and our 1 times 16 is. So really this 3a part just simplified out. We don't have it. Same thing over here. So we have 3a squared times 4 to the 0. 3a squared is going to be 9a squared, because 3 squared is 9, a squared is a squared. Well, 4 to the 0 is, which is give us just that first term squared. Does that kind of make sense? So we don't necessarily write it in. It is, for the set problem, that it is 4 to the 0 going up, and the same with 3a. Now what's interesting with this, because if we think about it, this is going from the 0 power to the first squared, so it's increasing. A is going to 1, 0. So the powers of the first one are decreasing, the powers of the second are increasing. We just don't write the zeros. I don't have to include either one of these here. Does that make sense? But that's, does that kind of answer your question? Because I think this is what you were asking when I said we don't include it.
Yeah, how come the 3a doesn't like a 3 on the square? Why does it continue? Why does it stop at the second?
Well, the one at the third spot would be our 3a to the 0.
Oh, so it's going down?
It's going down as the 4 is going up. One's going down, one's going up. And most formulas don't include the 0. We just say square 1, 1, square. You're welcome. And now the last thing we need to do is to simplify. So the 3a plus 4 is just going to stay 3a plus 4. Now our 3a squared, we're going to square this. So 3 squared is 9, and our a squared is a squared. We're just multiplying it by itself. So 3a times 3a is 9a squared. Our middle term, 3a times 4. Our 3 times 4 is 12. And we have our a plus 4 squared is, and that's it. Questions on this here? Let's look at this next one here. We have 192 x to the third and 81 y to the third. Out of these two here, we do have one that we can do easily, x to the third, y to the third, because the cubed root of our x to the third is x, cubed root of y to the third is y. Now we just need to see what the cubed root of 192 and 81 is. Cubed root of 81 is, well, that's not a nice number. And neither is 192. Before we can say that, is there a greatest common factor between 192 and 81? Because 81 is divisible by 9, it would be 9. 192, unfortunately, is not divisible by 9. 81 divided by 3 is 27. 192 divided by 3 is 64. So we can factor out a 3. And if we factor the 3 out, we do have 64 x to the third minus 27 y to the third. Okay. So now we're not taking the cubed root of 192 anymore. It'd be 64. And 81 is now 27. Do we know what the cubed root of 64 is? 4. And our cubed root of 27 is? Well, the last problem?
Is it the same one?
24. And
You did those on the
yeah, we did those on the last problem.
Yeah.
We took the cubed root of 27 on the last problem, yes? We got it as 3. 64 as 4. Question? Yeah, cubed root of 64 is still 4. So 4x, 3y. Any questions on this here? Questions? Three spaces, 4 spaces. Our signs, same, opposite, always end on a positive note. So for it to be the same, we would need it to be minus. Opposite is plus, and always ended on a positive note. So plus. Our first term in this case is?
Wait, what?
First term?
I thought it would be like if it started with minus, it ended with minus.
It's always going to end in a plus. Always ended on a positive note.
Doing it wrong.
So they don't just alternate. So it's going to be the same, opposite, always end on a positive note. So the last sign will always be plus. Last sign will always be plus. And part of the reason that the last sign is always going to be the plus is because to get this, so here 64, plus 64, we're doing this 4 times 16. To get that last constant term is going to be 4 times 16. In the previous one, to get that negative, we're going to have that negative 4 times 16, so the negative times that positive to give us the negative. Okay. Questions? So our first term in this case is 4x, because it's coming from that first term of 64x cubed. So here we'd have 4x. In the bigger set of parentheses, our first one would be 4x squared. The middle would be 4x to the first. Then the last one would technically be 4x to the 0, but we don't have to put it because of it's just a multiplication of 1. Our second term is 3y. So we'd have 3y. We wouldn't have it with the first because it's to the 0. The middle would be 3y to the first, and last would be 3y squared. Now, when y'all are doing these here, you don't have to do these one at a time, because if you know the first term is 4x and the second term is 3y, you can go on and just fill those in from left to right, because we could do 4x, 3y, 4x squared, 4x times 3y, 3y squared. Or if you want to put them in one at a time, that works too. Now at this point here, we still need the 3, the greatest common factor of 3, as part of our answer. 4x minus 3y simplifies to just 4x minus 3y. Our 4x squared simplifies to 16x squared, because 4x squared, we're multiplying it by itself. So 4x times 4x, our 4 times 4 is 16. X times x is x squared. Plus 4x times 3y. 4 times 3 is? And then we would have x, y. Because our x times y would be xy. Plus 3y squared and y squared. So even though we did have two variables, x and y, they still work the exact same, yes? Any questions on this here? We feel pretty comfortable with these here. Yes? Let's look at this one here. This will be the last one of cubics that we'll do. And then we're going to look at our last type of factoring after this, which is factoring by grouping. Now the cubed root of x to the third is x. Now we do need to take the cubed root of 125, and it is 5. Small set of parentheses with 3 spots, bigger set of parentheses with 5. We're going to fill in our signs. Same, opposite, always end on a positive note. So it would be minus, plus, plus. Same, opposite, always end on a positive note. Our first term would be x, yes? It's not. It's not 25, it is 5. Mm-hmm.
No, he did, because I legit wrote it down, and he was like, well, it's not.
Taylor? So the reason it's first is because which number, our cube number came first? 125. So that's why the 5 goes first. And then the x would go second. Inside our parentheses, we would have 5 squared, 5 to the first. And that's it. Then we can fill in our x and x. It's the amount of surface area that's touching the screen. Because fine point, or kind of a more point, it recognizes as one touch, and then a thicker.
This whole time I thought it was like reading his mind or something. I was like, I'm getting really.
He's so creative. I was not one her.
I was like, wow, he's getting
Well,
lucky.
You want me to throw this back at you? Or do you just want to make sure?
Sure.
I don't trust myself.
Maybe you should be in that sport.
Yeah, maybe not.
Stick to.
Maybe she's 6. I think it's a hard thing.
Yeah, I thought
So last thing we need to do is simplify. 5 squared is 25. Our 5 times x is 5x. And lastly, our x squared is x squared. Now, if we wanted to rewrite this, we could as negative x plus 5 times x squared plus 5x plus 25. We can, we don't have to. But that is another way to write it, so where we have the variables first. Don't have to, but it is another way to write it. Questions on this here? This is the last type of factoring, factoring by grouping. I sometimes call it or think of it as greatest common factor twice. But when we factor by grouping, we're going to group these into an even number of groups. So we're going to group the first 2 together and the second 2 together. Yes and no. This was 4, 4, 2. So you did, this was one of the extra lessons we didn't get to. And to do this, we look at the first 2 and see if there's a greatest common factor. And whatever it is, we're going to factor it out. Now, between 2 and 5, there's not one, but our p cubed and p squared, there's a greatest common factor of p squared. And we can remove it from both terms. And when we remove p squared from 2p cubed, we're left with 2p. And when we factor a p squared out of 5p squared, we're left with 5. Plus. Greatest common factor between 6p and 15. This 3 does go into 6 and 15. When we factor out the 6 or the 3 from 6p, we're left with. And when we factor the 3 out of 15, we're left with 5. Okay, so we did pretty much a greatest common factor between the 2 sets, yes? Is there a greatest common factor between these 2 terms now? Because this one has 2p plus 5. And this one also has it, yes? And that's the whole thing with grouping or factoring by grouping, is we group them up so that I can pull a greatest common factor out, which will leave one in common with both. And we could factor, again, the 2p plus 5 out of both. And if we factor the 2p plus 5 out of this first expression here, all we're left with is p squared. And if we factor it out of our second term, all that's left is our plus 3. And that's it. Questions on this here? There will be, for the ones we'll do, we're not going to look at one that's not. because then it just wouldn't go anywhere. And really, the way that we match them up really doesn't matter. We can do the first two, last two is a little bit easier because we could do it different. Now, there are some combinations that wouldn't work so well. 2p cubed and 15 wouldn't work well because they don't have anything in common. Neither do the middle two. So some combinations work well, some won't. First two, last two, because again, what we're trying to do is factor out a like term so that we do get those two sets of parentheses that are the same, and we can factor it out. Second, 3 into the third minus 4n squared. What is our greatest common factor? N squared. And we factor the n squared out. We're left with 3n minus 4, yes? Now, once we get one of them simplified, realistically, we can use this as kind of a cheat sheet. Because for us to be able to factor out again, I need to have the 3n minus 4 in common in both, yes? So that means for us over here, we need to factor something out of the 9n minus 12 to get it to become 3n minus 4, yes? What can I factor out of 9n to get 3n? 3. Positive 3. And we can do the same thing with our negative 12. Factor out of 3 to get negative 4. Which does give us this set of terms in common, which we can factor out, leaving us with n squared plus 3. Questions on this here? We ready for the next one? Twelve into the third plus 4n squared. So 4 is the greatest common factor between 12 and 4. It would indeed be 4n squared. Because both of them do have n, yes? Now, the most that we can take out of n to the third and n squared, there's at least 2 in both, yes? So we can take out n squared. We can take 2 of them out.
So does it have to be like third common? It just has to be the same.
They share 2 n's in both, yes. Yeah. So when we factor a 4 out of 12, we're left with 3. And when we take n squared away from n to the third, we take 2 of them away. We're left with 1. Plus 1. Because the 4n squared factors out completely, yes? Since we're not needing, when we look at the other one, the two signs are positive. We need them both to be positive, so it's going to be plus, because we're not having to change the signs. Oh, wait, what do we need this to be? What is it? It's already there, yes? And we're not going to do anything to it. But also, I mean, we can factor a 1 out, but it would still give us 3n plus 1. Also, there is no greatest common factor between 3n plus 3n and 1. But we do now have the 3n plus 1 in common with both. And when we factor it out of the first term, we're left with our 4n squared plus 1. Because whenever something factors out completely, it's reduced to 1. It will never become 0 when we factor out. So our final answer for this here is 3n plus 1 times 4n squared plus 1. Questions on this here? Now we do have one more that we'll look at, and then we'll be done for the day. I'll give you that because it is about Now, when we look at the next one, is there a greatest common factor? No.
Not 21.
I thought you grouped it together.
Yeah, we can group it together as these here. So 224 and 56, 2 is a common factor, but most likely it's not the greatest. Well,
56A.
What'd you say, man?
Yeah, that was not me.
so the calculator can help us with this to see. Math. So the graphing calculator, if we hit math and go over to 1, and all the way at the very bottom, it's greatest common denominator, or it also works as greatest common factor. We can plug 2 numbers in here. So the first number we can plug in is 224. The button above 7 will give us a comma, 56. And the greatest common factor between 224 and 56 actually works out to be 56.
It's like whole time I'm fixing it. I just been like putting divide by all the numbers off, and it takes me like
256 or 224 divided by 66 is 4. So for our first one here, it is actually 56A, because the greatest common factor between 224 and 56 is actually 56. And they do both have an A in common, so we can factor both of those out. When we factor 56 out of 224, we're left with 4 and Z. Plus, the 56 factors out completely. The A factors out completely, leaving us with C. Questions on this first part? Well, this is kind of helpful because if we look at the other one, trying to figure out the greatest common factor between 84 and 21, might take us a minute, but we know that whenever we do factor that term out, we should end up with 4Z plus C, yes? And the plus C is kind of helpful because we know we're going from negative 21YC to C, yes? And it would be minus, because we're trying to go from negative to positive. And 84 divided by 21 is 4. So our common factor there is negative 21y. Now at this point here, we can factor out our common term of 4z plus c from both, which will leave us with 56a minus 21y. Now there is one thing interesting with this here is 56 and 21. Do have a greatest common factor of 7. So what we can do with this here is actually factor that 7 out, which will leave us with 8a minus 3y. We still do have the 4z plus c. So this here is completely factored. If you don't notice that and just factor it down to here, that's fine too. The one on bottom is completely factored. The one on top of it, immediately above it, is just factored. Questions on this here? So really, what we could have done is at the beginning, we could have factored that 7 out, which would have reduced the numbers and made it a little bit easier to work with. But that is it for that there.